I was much amused by the discussion before the break about what else you could do with CO2, and the answer isn't much for two reasons. One is that the atmosphere and the land surface are in fairly short-term equilibrium with one another. And the only way to take the CO2 out of that coupled system is to put it somewhere where it stays for a long time. And that means either the bottom of the ocean or deep underground. The second point I was amused by is everybody says, well, can't we do something else with CO2? And there are two problems with that. This is the scientist talking. One is that CO2 is the end product of combustion for a good reason. It's a low-energy molecule. And if you want to do something with it, you have to add more energy. The second is that if you want to make a compound with it, calcium carbonate, a good example, seashells, right? You have to deal with, as exhaust from the power plant, roughly 8 times as much mass as you put in coal. So for every ton you put in coal, you've got to take away 8 tons of calcium carbonate. In my view, that's probably impractical. Never mind finding the 2.5 tons of calcium that you're going to have to bring into the power plant, okay? So getting rid of CO2 by putting it underground looks like about the best thing to be doing. The rationale is as follows. Power demand is going to grow, and we heard that already, disproportionately, because electrical power is what developing societies like as an energy source. Absent emissions, coal is going to be the dominant source of power for some time. There are abundant reserves, hundreds of years, if not thousands of years. It's cheap, it's easy to use, we know how to do it, and most importantly, it's co-located with demand. As the US, China, or India get nervous about energy security, they will increasingly turn to coal. Of course, the most emissions-laden of the fossil fuels, twice as bad as gas, almost twice as bad as, almost twice as bad as oil. And greenhouse gas emissions will likely be priced in the future, maybe not globally, certainly already in Europe, and very likely in the US soon. We think we can reconcile these two through hydrogen power, but you have to understand that a significant competitor, as was already mentioned, is nuclear fission, which will compete on cost and scale. We have, in fact, established a hydrogen energy business, which has announced already 4 projects in various stages of progression. One of them is killed already, and we can talk about why. The challenges are as follows. The integration and demonstration of the above-ground kit at scale. I am, again, amused and somewhat horrified at the certainty with which various business folks, and even more so the politicians, talk about carbon capture and storage as a way of making material electrical power with low emissions. The technical folks believe it is plausible, certainly the above-ground bit, but has yet to be demonstrated at scale. No one has built one of these plants yet. It's not so easy. The integrity of underground storage. The stuff has to stay down there for 1,000 years, because that's how long carbon lives in the atmosphere. We have fair confidence, but not proof yet, that that will be the case in depleted oil reservoirs, particularly with enhanced oil recovery as part of the story. Enhanced oil recovery is an important part of the economics in this, but is a negative part of the carbon balance, because you're pushing more carbon out of the ground as you're pushing the CO2 down there. Ultimately, because of that reason, and maybe more importantly, because there's much more capacity in saline aquifers, as was already mentioned this morning, that's where we need to do it. Yet we need to be able to guarantee that integrity for 1,000 years with only 5 to 10 years of observations and measurements. A tough technical challenge. We need to reduce costs through optimization and scale. Here, particularly, membranes are a very important technology that needs to be developed, whether for capturing the CO2 or for separating out the CO2 from CO from hydrogen. There are legal issues, and this is where the technology meets the economics and the policy. What criteria do we have for monitoring the CO2 under the ground? What are the liabilities? BP will not likely be around in 100 years, much less 500 years. Who's got the responsibility if and when it starts to leak? Unresolved issues. Ask the state of California, they'll shrug their shoulders. And so by proposing these projects, we are pushing the system. And then there's public acceptance. The somewhat, actually quite imprecise analogy between CO2 storage and nuclear waste storage, and the issue of public accepting pipelines that move CO2 around. In fact, pipelines of any significant sort is not an easy thing to get in.